In a previous episode, we built our first logic circuits with some batteries, switches, and light bulbs. While that's a great demo, you already know that that's not really how logic gates are made. So in this episode, we'll look at some real semiconductor logic gates and introduce you to a really amazing logic kit from our friends over at LittleBits. The first trick in building a circuit with a modern logic gate is figuring out how to attach wires to it. You see, all of the functionality, now not necessarily the same wiring of course, of the big board is included in the very small package, and it's called a pico gate. There it is right there. It's about 1 millimeter by 1 millimeter in size. Now imagine trying to connect wires to that. So what we will use to show you these logic functions is a clever product from a company that's called LittleBits, and this is one of them right here. It's a modular design where each logic gate is on its own little board. The best part is that to connect one module to another, all you have to do is bring them close and they magnetically interconnect. So let's hook up our first circuit. First, we need a power supply. That's done by this module that steps the 9 volts out of a battery down to a safe 3.3 volts for the logic gate. Next, we use a splitter to connect this 3.3 volt supply to our 2 different input switches. Then it's time for the gate. The first one we will use is the AND gate. And finally, we need some way to know the output of the gate, so we will attach an LED module. And there you have it, your first logic circuit that took less than a minute to assemble. Now remember how the AND gate works. Only if both A and B are on will the output be on. So we press both A and B, and indeed, the LED turns on. But the best part of LittleBits is the ability to try out a new circuit very quickly. You want to see the OR gate work? It only takes a couple of seconds to remove the AND function module and insert the OR module. And there you have it. If either A or B are pressed, the LED lights. And this is a fun one. Remember the XOR, the exclusive OR? In this function, the output is on only if A or B, but not both, are pressed. As you might remember, this is the core for all computing because it actually does binary adding. 1 plus 0 is 1. 0 plus 1 is 1. But 1 plus 1 is a binary 2, which puts a 0 in that column and then carries a 1. So along with a carry circuit, this exclusive OR is doing math. You might be thinking, sure, these are fun little toys, but what are they really good for? The answer is quite a bit. You see, LittleBits is a lot more than just a couple of logic gates. There are several different types of functions which are defined by the color of the module. The blue ones are power supplies. The pink ones are inputs. The orange ones are links or connectors or wires, and the green ones are outputs. So you can use other inputs than just a push button. For example, suppose you wanted to build a circuit to control a room light so that it can only be used at the night. This means logically that you want the light to turn on only if both the button is pressed and it is dark outside. So let's replace one of the switches with a dark sensor. Now see what happens. Only if the button is pressed and it is dark outside will the LED light up. Or maybe you don't want a light to switch on. You'd rather that if you push the button and it is light out, that the window shade closes itself so your room gets darker. So we replace the LED light with a motor that you somehow connect to your window shades. Since we want the motor to close the shade only when the sun is bright, we want the opposite of dark, which we can do with an inverter. So now, when it is light outside and you press the button, the motor turns on and the window shade closes. Oh, and it can also trigger an alarm, so if the cat is sleeping on the windowsill, it chases it out of the way. But for logic applications, this has to be one of the neatest modules, and it is called a latch. Let's go back to our simple AND circuit, but now we add the latch to the output side. When we press A and B, see what happens. Even though we only briefly press the buttons, the circuit remembers the answer until we change it. We have just demonstrated one bit of memory. Only a few billion more of these circuits, and you can start to build your own tablet from scratch. I think I'm going to need some more space around here. All we've looked at so far are the logic modules. LittleBits is far more than that, however. There are also sound modules and display modules and special modules with microcontrollers and sequencers. You can check out their entire product line on their website at www.littlebits.cc. And there you have it. Finally, some real logic circuits made with real silicon logic devices. So go out and get a set on your own and start playing with logic.